I have an extremely tough act to follow behind Norm, because Norm is a monstrous presenter, so I'm going to need you all to try to stay with me a little bit, because there have been some changes to what we had just seen that was worth warranting to do a second presentation on. We had spent some time. Did we want to build this into one? Could we survive with one out the other? But there was just enough difference between them that we ended up doing two. And so I appreciate everyone sticking around for the second part of it, called the Adolescence of the LabVIEW State Machine. So, what are we going to talk about today? We'll talk about how we got there. We'll talk about learning to walk, growing up, a demo, and then finally some wrap-up, and hopefully a few laughs along the way. So, how did we get here? Norm just talked about TLB prime in the sense of, I have this idea of a queue-driven message handler, and I have this idea of a state machine. And those two things can work in conjunction together to ensure that your system does what it's supposed to when it gets certain triggers. All right? So that's how we ended up getting here, solving the problem of just having the queue-driven message handler on its own. Talk about real applications. So a lot of these things when it comes to templates, it's sort of like mythical hand-waving unicorn in the sky, being like, yeah, it's there, but did it really do anything useful from a practical standpoint? This is one that I was just recently working on, a channel emulator, that the background has a... No, I should have had a mouse. Hold on. We can do it. I have a mouse that doesn't do anything. Is that good? Not good. Oh, there we go. So over here, you'll notice the front panel. Looks similar to that. It's actually a decent looking UI that was able to do a bunch of different things for our given customer. One or two channels. Also had the built-in error handling and loading some files and all that kind of good stuff. But the important about this whole idea was, if you can resolve your program into something that looks like this, this works very, very well with top-level baseline prime. And being able to sort through, I go through a startup, I go through idle, I go through connected, acquired, and I can look at these triggers and figuring out what should my application be able to actually do. Beyond just the real application, this exists in a whole bunch of other places that you might see pop up. There are several reference architectures from RFSE, the WLAN PA test panel. You'll see some of it in the STS. I put an asterisk up there. I'm probably going to get some grief from my idea of a test sequencer. It does very well. You can set up a queue of actions and it will behave the way that it's supposed to. Now that being said, NI has this product called TestStand. TestStand's been around for a long time and has a whole bunch of development time from R&D behind it. Alright, so if you have a choice of using TestStand, I take a real good long hard look at using that rather than just jumping to this and say, oh, well I can just use this and whatever. But that being said, it has solved problems both on this continent and other continents, so it can be done. And there's a whole bunch of other ones that exist. All right, so as I spent some time, I've been doing, my name is, I've apparently missed a slide about who I am. My name is Aaron Ryan. I am a senior field application systems engineer based in Colorado, and I have been working with TLB Prime for probably 7 years. It was the first real project I would say I did in conjunction with other SEs that are here, and Norm was kind enough to take me under his wing. Being a person of biomedical engineering background, you can about guess how much software experience I had. So I was able to pick up TLB Prime, so that shouldn't scare off people. But as I spent some time working through this and talking to Norm, and I essentially came to this part about, insanity is doing the same thing over and over again and expecting different results, and specifically from Albert Einstein. And what am I talking about? That from an application standpoint, there are certain items that I just felt like I did it over and over and over again. And those usual suspects ended up being configuration-based, asynchronous process registration, UI display, and then finally error handling. So the course of the rest of this presentation is really going to focus on those specific 4 items. All right. So you probably get this from your customers, or maybe even ask yourself, how do you go about configuring your system? Do you rely on someone to go in there and press some buttons and hopefully they set it up right? Do you save your front panel values? Maybe. For at least my experience, the vast majority of folks want this idea of load from file. I'm like, okay, we'll load from file. And then he follows up with, well, I don't want your file type. That is okay. TLB Prime now introduced the idea of a configuration-based load, essentially a serializer, with its object-based. So if you want an INI implementation, or you want JSON, XML, your own custom formatting, whatever that happens to be, we now have a home for that inside of the actual framework itself. What does that look like? In the actions that exist, over here on the right, I'll get some file path information. I create, I take a look at a directory, I perform some serialization on it, and spit back out what my class is going to be. So now you have a placeholder that if you want a certain type of class to be loaded based upon your configuration, you can do that. In there, where all the magic actually happens, is the variant to class and class to variant, where one neat thing about variants, they actually have their data types within them, and you can get that information. So you can actually do a lookup so you can typecast that data accordingly. So, in here are the guts. You go to the class of the variant, you go to the property bag, you get out what you want, and you stick it back in for your configuration. You're like, that is awesome. So, we now have a dedicated place inside of the code to handle loading, say, station configuration, hardware limits, anything that you ever wanted to know about your given one. That is nice, because now you're not relying on front panels. You're going for the deployment scenario of I can update a configuration file and not have to do a redeployment, which is very helpful. And then finally, it's class-based. So if you have a customer that wants INI, or like I said before, just wants a plain text file, you can now build a reusable component across a whole bunch of different projects. All right, so configuration was the first one. Who here has had this problem of asynchronous process registration? Everybody's got that guy that spun up a VI, and it's like, where did you go? What are you doing? What's going on? And so now, as part of this framework that I'm going to show here in a little bit, we have a way of not only tracking static or dynamic launches, but we're also going to give you a mechanism by which you can wrangle them back in case they start to unbehave correctly. So everybody's had a VI that's not gone out of control, right? Everybody's got that project in there where it's like the library's locked. It's like, what? Who's running? Why didn't you die the way you were supposed to? Yeah, that's happened. So, what does that look like now? As part of the framework, I now give you the ability, or I guess we give you the ability right now, of being able to essentially register yourself with the system. And you'll notice the type of the queue is the VI reference. And so that's actually going to be very, very important for what we want to do. In addition to this dynamic registration, so over here on the left, I have my pointer to go ahead and get a path, kick off a reference using the asynchronous node, and I go ahead and close it out. I'll also point out the other key part about this is I needed a static VI reference to be able to make this all work. So this code right here is a sub-VI located within whatever process I'm going to go spin up. All right. Also located within this sub-process, there's this idea of a last act. And this is the idea of, okay, I spun you up, but sometimes you need to make sure that your code comes back, right? How do people handle that? What do you do? Hit hope and pray? Yeah. In this case, we ended up using a notification for being able to, and this is not the only way I would say to go about solving this given problem, but this is the implementation that we chose. So inside of this VI that is spun up, there is a sub-VI that does this for you. So now we have a last act and we have a registration. What does this mean for the caller? That static VI reference that I had just previously showed, that's where that's going to come into play. Because I have access to that reference, I can go look at the individual paths that exist. Hey, you know what would be a mouse that actually worked out here would be good? Yeah. Okay, anyway. So I get the reference to this. I can go look up all the names. I can see how many of them actually exist, and I can pull their references. From there, I can get the names to them, and I can say, hey, you know, what notifiers out there that got created were good that I can go ahead and take advantage of. So this is all code built in. You now have access to essentially any VI that's been spun up with inside your system within that application instance. So if you have a VI reference, you can do anything. Well, maybe not anything, but you have a whole bunch of options that exist of how you can go ahead and take advantage of that reference. So you probably ask yourself, and how about wrangling? What does that really mean, and what can we do with that? So as part of the framework now, if you go ahead and spin up your VI accordingly and it registers with the system, we're going to use VI server to take advantage of the fact that I can now open that orphans front panel. So if you're registered, I can do something with you. So in this case, it's like, hey, what VI is still running? And I'm going to show some demos of this here in a little bit. No one likes the orphan VI that's running that didn't die the way that it was supposed to. No one likes that. Locked libraries are no good. Okay. The second part, I guess the third part that we added, was the idea of UI displays. And it goes back to this idea of how many event handlers do you need? How many do you want? Like, what goes in them? Do I have controls? Do I have indicators? Do I have both? What does that start looking like if you have sub-VIs that exist or other asynchronous processes that you need to update your front panel? And those are all questions that have been solved a variety of different ways. What we ended up going down the road of was 2 event handlers. One of them specifically dedicated to UI button presses, and another one specifically for button indications. So up here in the upper left-hand corner, you'll notice there's the event handling loop where I'm going ahead and just catching in controls, and then down here is actually where the indications will happen. So now you have dedicated placeholders for where that information is supposed to live. Now, that comes with a little bit of baggage, I would say. First of all, this proverbial how you stop 2 loops in LabVIEW. So you have that problem, which we definitely solved. The other one is, what about the event registrations? You know, having a second one of those that you have to go ahead and destroy. So there's a little bit of overhead that's associated with that. But it does give you a guaranteed place of where you want to go about handling your button presses, catching your indications, and then finally it provides a clear place where those items should actually live. All right? So everybody likes UIs that have homes. Now, probably the biggest change to this is the addition of an error handler. Everybody's seen the Bobs. So, error handler, what is it you say that you do here? All right? According to the internet, error handling refers to the anticipation, detection, and resolution of programming, application, and communication errors. Specialized programs called error handlers are available in some applications. Well, that some has now come to TLB Prime. Sure, everybody's seen error handling strategies like this, right? We'll just have LabVIEW do something about it. Everybody has great error handling, right? It's everybody's favorite topic. It's actually, error handling is not one of the easiest things to do and to do well. And as soon as you start spinning up asynchronous threads, things get a lot more exciting, a lot quicker. But that is not a strategy. The second point, that is an error indication. That's not helpful. And then this, I'm sure everyone's seen a block diagram where you have the global smite. Of like, I don't care what went wrong, goodbye. I'm not saying you can't do it. It can be done, but it's probably not the best idea because it's like, I don't know if my TCP reference didn't open. I don't know if my user did something wrong. I have no idea. I just crushed it. So this gets us to the point of asking some questions. So does your application really need to stop itself despite the kind of error? Maybe. Or should it alert the user and have them take some semblance of a corrective action? Or better yet, based upon what state I'm in, I know what corrective actions to take based upon what has already happened. That is actually really important, and that's the point in the presentation where now it's rating error handlers. Because there's now something in there that we have a very, very specific mechanism for being able to track what's going on and what can we actually do about it. So, just in case if anyone's curious, those falling error handlers took a long time to do, so it's totally worth it. Totally worth it. So, and it goes back to this thing about, okay, I put this in there. You may not like my error handler. You're like, I don't like your implementation. I don't like what you did. It's fine. I don't care. I do care, but I really don't. But when it comes to it's a LabVIEW object. So if you don't like the implementations that I'm going to about to show here in a little bit, you can overwrite them. You can make them your own. You can extend them if you'd like. So what does this look like now? So during the actions of when my application spins up, I have an error handler, I pass it a path, and I go ahead and start creating my resources for my class object. So the error handling itself, I've tried to think of it like Newton's third law-ish, okay? It's not physics, but for every action, there's going to be an equal and opposite reaction that exists. And this is going to be important. So down here, I have this idea of, action foo errors. I have a capture error, and then finally, I'm going to have some semblance of a decision. So let's get a bit more into the nuts and bolts of what does this actually look like. So, everyone on the same page. Over here, we have an event handler loop that is going to generate system triggers. Now, system triggers, as Norm just pointed out, don't specifically have to come from there. But for the sake of this demo that I'm going to do in discussion, we're going to assume that's going to come from there. In addition to that, we have the actions over here, the brawn of the primary execution loop that actually does the actions. And then finally, the brain that stayed aware and knows what to do when certain triggers come to meet. All right. So let's just say, for example, I have a front panel and someone presses my button of connect. All right. What does that mean for my actual code from just a diagram perspective? So the event handler that I've registered an event for my connect, will get caught, it will go to the brain. The brain, which is system aware, is now, first of all, compartmentalized into a sub-BI. That is one thing that will look drastically different from the folks that have seen TLB prime in the past. But the brain takes a look at that trigger and is like, okay, what am I supposed to do with that? The brain, in turn, enqueues the do actions of whatever that happens to be. I go do my actions. All right, so let's just say, for instance, maybe one of my do actions was I wanted to open up a session to RFSG. All right. So out of there, say our user made a mistake, or the coder didn't do what they were supposed to do. They forgot to wire in a handle to it, and it throws this error code being that, hey, this device identifier is invalid. That's an error, right? It's like, okay, so my action foo has errored. What do we do? So my do action that I just shown with RFSG, RFSA, now goes over to the brain. The brain's like, okay, I have caught your error. Let's figure out what we're going to do with it. So inside of the brain, I'm going to have my little error coming right in here, and it's going to go in to get cached to the error handler. So the error handler now has information about not only what the error was, but I also know what's going on with my action queue in addition to my state and originating state. This is all going to be important information. So now that I've captured it and categorized the error, what can I do with it? At this point in time in the program, I know what actions have been done. I know what the erroring action was. I know the remaining actions. I have access to the error itself. I have the current state, destination state. You have everything you need now to self-correct if you want to. Oh, rating. For being able to do that. And so we have some decisions now. So at this point in time, we can do a couple of things. I could just look at what it was and just self-correct. If I don't want to do that, you'll notice down here, I know it's a little small, I got it. There is this polymorphic VI down here for this flush, log, and dialog. Also, as part of the framework now, there are polymorphic error handling actions. So yes, you can self-correct. If you don't necessarily want to do that and give the user, maybe say, you want to just flush and log the error. So say something fails on startup, and it's a key component to your system. You can flush and log the error, and your system can shut down gracefully. Maybe you're mid-execution of what actually your program is. You can now maybe prompt the user being like, hey, I want you to do something about this. So those are now also included in there. So those are the 6 options that you get. So the brain being whatever you chose to do as part of the brain will then in turn have corrective handling actions to essentially undo what you had previously done, which is different from any of the other queue-driven message handler that I've seen. So you simply can unspin up what you had previously done. The error dialog. So I mentioned before about those polymorphic actions that you have, the flush, log, dialog. This is what the dialog looks like. And out of there, it's worth noting a couple of things. One is that I tell you what the error code actually is. So that's helpful. Whoops. Keypad is very sensitive. Yeah, I'm trying to, it's not a lot hard to do with that. So I tell you the error code. In addition to that, I tell you where it was at. I tell you where you were, what you actually did, what caused the error, what actions are left, and where are you going to. So you look at this error dialog and you're like, I think it's stupid. I'm not an art person, but I have a way better one. Fine. Picture control, you can do whatever you want out of there. But this is, like I mentioned before, it's a dynamically dispatched gateway. You can do with it what you want to make your dialog look accordingly. But the point is you have access to a whole bunch of information that you can now say, hey, do you want to return to safe state? If you know all these things, you can tell what does return to safe state mean for me based upon where I'm at. Or if you're like, I bombed out, I just want to shut down. You can have that now too. So that error dialog, maybe pops up with return to safe state, or maybe it's shut down. That information via that switch of this or this, so you can have multiple ones, goes back to the brain. The brain's like, okay, you just told me what you wanted me to do. Inside the brain, with access to the originating state, the error cause and action, the destination state, I can go ahead and take whatever corrective actions that I want to be able to do. As also part of a decision if you just do not want self-correcting. Okay? The brain in turn is like, okay, you told me to take some corrective actions. I go ahead and execute whatever those are to get my program back to wherever it needs to be. So what does this actually mean? So first of all, when you're talking about the errors themselves, you're going to have to define what do these errors mean and which ones are recoverable, which hopefully everyone should probably be thinking about doing anyway. In addition to that, you need to figure out what the inverse of what those potential actions might be. So it's going to require you to think through your states and actions in order to back them out. What does this give you from a benefit standpoint? It's a real application error handler. That's huge. That there's built-in now functionality. I don't think anyone's tried to solve the problem of error handling, but it can be a real pain to do it. And now there's a template. They're not encouraging you to just go throw away your template that you've been working with for however long. I'm just saying, and give a real good, long, hard look at what this now gives you from a starting off standpoint. It's a class-based implementation. It's reusable across a bunch of different projects, and it requires you to think through your states in order to back them out. That's really important. All right, let's see a demo of this. All right. So a couple of things I wanted to show was, first of all, I mentioned there's system configuration. So being part of system configuration, I have this INI implementation. And so let's go ahead and set, what? It's called NIWeek 2017. So Rio 1 and DMA depth of that is fine. All right. So a couple of things before we get going about this is that here is the actual diagram of this code that I was working on. So we have startup, we have idle. Idle sits there until it gets a trigger of connected. Connected hangs out and does its thing while the user does some configuration. You start acquiring, you hang out and acquire until someone says stop, and you go back to connected, disconnected. So it's a very much organized flow that can be represented with, I used YED for this as a free editor, so it's pretty awesome for doing demos and showing off state diagrams. All right, so I just configured my station to say, hey, I want to do NIWeek 2017 with this Rio 1 for my actual code. So if I run this, a couple of things worth noting. You'll notice that this name actually changed. So configuration stuff, neat. Here's Rio 1. In addition to that, I'm trying to illustrate this idea about what's actually happening. Over here on the left, I've actually spun up an asynchronous VI that I've registered for. And this is essentially going to monitor my action queue as I press buttons. So this particular application isn't really anything fancy. It's going to connect to some hardware. There's going to be some math that gets done. There's going to get the user back some display. Okay? So I say connect. Doing some simulation stuff. Up in the upper right-hand corner, you'll also notice we added the idea of essentially statefully aware. So if I go to connected, I actually tell someone I'm in connected, and it's in a different color. So if I go back, you'll see it goes back to idle and to connected. All right. When I do that, it's going back for the statefully aware. When I went to connected, you'll notice that the Rio device name and the FIFO depth are now set, because I've essentially opened up handles to those resources. So I don't want to change them now. But when I did that, I got access to my tone frequency. I can specify how many samples I want to read out at a time. So let's just say, for instance, I want to go ahead and start acquiring. All right. So to start acquisition, we'll get going here, and I got my tone at 10 megahertz. Like, that's neat. Let's say the user does something silly that they shouldn't do. You'll notice down here I have a maximum tone frequency of 50 megahertz. Let's just say they do something goofy. Oh no! So I tell them what the error code is. I tell them where it came from. I give them some information about the... There we go. I give them some information about, hey, what happened? It's like the 100 megahertz violates the NIWeek theorem from what this actually is. And so at this point in time, in your application, you have some choices to make. I could have not thrown a dialog and just corrected it, right? Maybe I don't want to do that, and I want to make the user make some choices about, hey, what corrective action should you take? So if you say the idea of return to safe state, in this particular implementation, I decided to alert the user as to what went wrong. So I can go ahead and be like, hey, your 100 megahertz is wrong. You should really do something about that. So I just blinked it. You'll also notice there on the left, I know it was quick, but you saw a whole bunch of list of actions that got queued based upon the answer that they had selected. So let's go back to, say, 25 megahertz. Okay, let's start execution. Did everybody see that spin by on the left? I know it was quick. Yeah, it's pretty fast. Okay, so anyway, we're going to get going and get back to 25 megahertz. Alright, so I get my tone at 25 megahertz. Maybe the user makes another mistake and was like, hey, let's say this is going to be 5 samples at a time. DMA FIFOs will overflow eventually, depending upon how deep you make them and how long they're going to run for, they can overflow. But with that, it says, hey, you know what? The DMA overflowed. This is where we were at. This is what we were doing. What can we do about this? And so I have the option right now of shutting down and returning to safe state. But because I know where I was at and what I was doing, I can still go back to safe state, and it will self-correct that behavior that was previously not there. Yeah. The program does not automatically do that for you. You are going to have to write a little bit of code to figure out what does it mean for me to unspin up or undo essentially what I had done and getting back to a safe mode of operation. And there may be moments where you have an error that is not recoverable and it's like, shut down. Goodbye, you're done. Other parts about this that I wanted to highlight was that I mentioned before that you click on your disconnect, things happen. If I go to shutdown, what happened? Oh, my tab resize didn't shut down correctly. Oh, that's devastating. Told me where I was at and everything. Open front panel. You can find out whoever was lost for being able to do that as being built into that. So that's actually extremely, extremely powerful. And just to prove it's all completely smoke and mirrors. It's real, I swear. Enable this sub-diagram. If I run this again. And I just shut down. Everybody shuts down the way they're supposed to. Yeah, sure. There's a whole bunch of different reasons why. Let's take a look at one, actually. Oops. So I mentioned before there's this whole action monitoring one that exists. Imagine, for instance, that maybe we didn't register for the right event here for a shutdown. Or maybe something else happened that it had another loop that was running for being able to make that. So unless you make it to here, you don't necessarily get a notification for that, for being able to shut down. So didn't get a message, maybe you errored, something like that. But out of this guy, there was a question asked earlier about, what does this process registration look like? And so in there, when I go to say, hey, check asynchronous process stop, you're going back to the notifiers from before about, hey, how do I know who has shut down? So using this idea of, hey, are you still with me? Essentially iterating over this is very important, because then I know when I'm in my shutdown, I essentially have a countdown timer of 5 seconds to say, hey, if I know all of these references are destroyed and they're not there anymore, I know I'm good. If not, I know something went wrong. And I being able to keep track of what VIs are actually left and I have the references to them. It doesn't matter if they were statically on launch or if their user was pressing a bunch of buttons and launching a whole bunch of them. It doesn't matter anymore. I now have access to all of their references. And I can get back their notifications or being able to shut them down. So very, very helpful. So essentially when Norm before was talking about in the actions, you really don't want those things to be blocking. This is one way to essentially mitigate what that problem is, essentially just iterating over it. Are you done? Are you done? Are you done? And not having that be blocking. Okay? All right. That is Perforce. So what does this mean for where we got to? So TLB prime, just as a recap of, hey, what did we do? So we have a queue-driven message handler and a state machine. TLB prime now has the ability to essentially have new demands. So folks are still working on this. I came back to NI somewhat recently, about 2 years ago, a year and a half ago, somewhere in there. That I ended up picking this thing back up and making those kinds of changes. So as feedback comes in for making different application, we're going to continue to make this better and continue to solve more problems with it. So new features that are currently in this right now are configuration, asynchronous process registration, dedicated UI display loop, and error handling that actually does something with errors, albeit you, the programmer, will need to decide what that actually means. The template as it stands can be found here. The actual release error handler one, Norm and I have not sorted out when we're going to get that out there, but it will be out soon. I didn't get a chance to package it because I was on vacation last week. And questions? Yes?
So why do you choose to do queue event
Sure. So there's a couple of things that led to that. One, from just a cleanliness standpoint of the diagram, it made it a lot easier to follow in the sense of indicators go here, button presses go here. And I've seen them where they have a whole bunch of, my worry with doing both button presses and folks updating the UI at the same time is that sometimes folks will get a little bit greedy. And they'll go, okay, I want to update the display, but I also want to change every other point to green and red. And all of a sudden their UI starts to slow down because they're doing a bunch of other processing in there where it's a very dedicated place of, I do not want my processing to stop my user from being able to press a button.
Maybe I misunderstood. There's not embedded structure in the UI display, right?
There's two of them. There's two event structures.
What events are being fired?
So indicators go in one.
So the events that are getting fired in the upper loop indeed should be interactive, or either externally received commands or button pushes inside. And another part of why that now exists, a lot of things you've seen, it's event loop up top, processing, and then the display one is now ducked below. The other big reason why that one exists down there is within the original TLB template, there was one action that was referred to as update indicators, so that all of your terminals would go there. And all data that would go to terminals was inside of the shift register. I still stand behind that choice. I still like it. However, one of the challenges with that is with every individual time that you did update one of those things that needed to get populated in the front panel, you needed to re-enqueue the action of explicitly update the front panel, update the display. So this was an attempt to not only allow for that updating of the display to happen outside so that you didn't have to kind of kick the update display dog every so often, but then also it allowed for other event-based, like status, to happen in the front panel itself.
Okay, so usually you just have this event structure with the one event, which is a user event that you.
Yeah, so it's one loop with one event structure with multiple cases on it that might be receiving different events to update different terminals.
Yep.
But now you know where all of your, ideally, in a perfect world, there's the one loop at the bottom that's typically a little bit bigger than that, that would have all of your indicator terminals at that location.
And the other part too became a problem with the fact that if you spun up, say, another asynchronous thread that didn't have necessarily a front panel, and now gave you a placeholder for being able to still update your main display without having to call the update display and queuing another trigger and an action to be able to make that happen.
Yeah, fire the trigger, and the trigger would have to get caught by the brand new the brain would have to say enqueue, update display, and update display would happen in there. So it's kind of the only way to hold paradigm. So this helps still hold paradigm without having to do a multi-hop every time that you want to update an indicator.
Yeah.
Would you still be able to handle value signaling events?
Yeah.
So in terms of value signaling, absolutely, because the value signaling would still be like, well, presuming that you're talking about a control, and indeed if it's a control in the front panel that you could change anyways, it's going to behave, that's the thing, the brain of the program is going to behave appropriately based off of whatever your value signaling was changed there. So indeed, if you're changing, so that's the thing, none of this actually talks about how the values, when you change a value, how it gets down into the processing loop itself. That's all in the TLB template. That still holds the same. What are you showing me?
Oh, I'm just showing that you can get lots of arrows going if you get the error handler in there.
That's it.
Yep. You're good.
But yes, so in terms of how value change events, like I have a numeric control and I change that, that is, I guess Aaron would have to show how that happens in there. Would you actually? But that does not happen down here. This is for updating indicators, not necessarily catching. Once again, that user event catching is more in that top loop,
Yep.
including something like value change.
Mm-hmm. Other questions? Concerns? It was like.
I want to illustrate something.
Sure, go ahead.
Because I'm not.
You good?
The idea of backing out individual actions. I saw a lot of heads nodding in the background, so that's good that people were catching on to it. But just in case, I wanted to really help drive it home because that is so important to the proper error handling strategy. If indeed your list of things from when you're idle going to connected is one action, initialize DMMs, another action, connect to this service over here, another action, start your TCP listener. Each one of those things are indeed actions that happen along the way, and almost every queue-driven message handler that I see just goes, there's an error, oh, go someplace else. And it leaves everything there, and then what ends up happening, leaves the current bits of the system incompatible with the state that it might be in. Right? It never really got to connected because you didn't do everything necessary to get to connected. So that backing out of actions is something that you as a developer still are beholden to program into your system. But at least now the flow is already designed to handle it. That idea of, can you pull up the slide that had like a list of things?
This one's trying to use it right now. Yeah.
It's,
Almost there. There we go.
I would like to, I want to poll, I know that you're trying to absorb right now and maybe not processing as much, but I'm curious for those of you who are processing as well. Is there more information that you think would be necessary in order to properly handle an error in your system, either to inform the user to make a choice or to handle it automatically in the background? This felt holistic to me and Aaron as we were talking through it, but I'd be curious as to, oh yeah, when I do it, I do it. Any thoughts? Please, honey. Okay, so a timestamp associated with it?
Write it down.
Skip it.
Step 2, pen.
What's that? Timestamp. Okay. Any, yes, please.
It's more of a user interface ability. You know, it's something that's occurring over and over and over again. Can you ignore it?
Oh, like has it happened multiple times? Like, go to something. Okay. Yeah, that's the one. How many times does this one happen? The error log is actually, that's one what it just came to me. So the one thing that he didn't really highlight is that it would have been a really neat demo is just there is a log that will happen in the background that will say, hey, here are the X number of errors that have happened, and it logs all this information.
Yep.
It logs all this information too. There you go. So you hopefully, yeah, let's go ahead and open it up. Let's see what you got. Let's see. You picked up visualizers from there.
So it tells you date, time. So there is that built into there.
Yep.
Whoa.
Oh, but that's just
Easy.
the error, so it didn't have all the rest of it, right?
What do you mean?
you have a lot of information that happened that caused the error.
Oh, at this point in time, when you're recording the actual error, I didn't think about putting in it for like a call log or essentially duplicating what's in the dialogue. That's a good idea.
What's queued up already in the trigger list? Yeah. Yep. That's a good one too. Yeah, maybe even like a log of the triggers. Yeah, I guess. Yeah, I guess there could be different errors. Has anybody used Synergy? Synergy has this great feature where you can set different debug levels, and it will either log everything that you do or log only the stuff that goes and it dies. So that would actually be a pretty interesting way of doing that. Yes.
You're almost sort of talking about here, but I know sometimes when you're troubleshooting those is what was the value, like an instrument of some sort of control, what were the values the instrument set to? So is the data that might be perfect?
So can you open up the state machine brain for showing an error? So the way that it flows is that information, well, the entire shifter, that big cluster, the shifter of the system as it's been coined, has a lot, potentially, of information. So doing a full dump of that might not be appropriate, but over to the right, let's walk through the flow of what happens. So over here, error comes in from the system, goes to this case, go to the default and no error case here. All right, so if no error happens here, it's, just pass through. But if indeed an error happens, it'll do as Aaron had mentioned previously, it'll log, hey, whatever's left in the queue, it'll get things ready, and then if I'm not mistaken, let's see, where's the error coming over here?
Error coming over here.
Yes, because you have to true, so I'm in a state, nope, because it doesn't go to the error state just yet.
Oh, yeah. So out of acquiring,
If I'm in the acquiring state, and an error has happened, so what ends up happening is a trigger gets in queued at the front that you haven't seen. That happens in that other case structure up immediately before this. So a trigger, an error trigger per se, makes its way onto this trigger queue, and so now the way that you think about how to handle your error is, I'm in this state, I've gotten an error, here's my information, what do I do? And now that Aaron has provided this enumeration, you can have a pre-prescribed list of things that make your life a little bit easier, and if I'm not mistaken, you want to pull that gray wire down?
Yeah.
It used to be, Aaron has made it a class inside of the program, but it just used to be a big cluster. All the same, now you have also all the information in the program to, one, make the choice as to what to do, what to show to the user, or even log that information, log even more. Does your log have more, an extra input to it?
Does my log?
Your log, your flush log data, flush log dial.
Good question. I know.
Where's the log?
How do I log?
Yes, how do you log?
I log it in action.
That's a good point. Yes, it is indeed an action. So let's go ahead and show log. There you go. So actually drop down and zoom into it a little bit. Drop down the actions. Okay. But in the actual actions themselves, there is a section of the individual actions dedicated towards handling just those few things. I want to do a drop down on the actions. Yeah, so if you zoom in there, you'll see that, error log and error dialog. So this would be the scenario where you could say, hey, log that in. This is actually where it's doing the logging to this. You could possibly pump more information into that. Maybe we need to put a string input on the error handler there for the log. So that the
additional comments or something like that.
Well, actually, it'd probably be best to put it into the error handler in the brain.
Yes, that's what I mean.
So there,
Yeah, no, not for the dialogue, but in the brain.
Yes, logged in as well. Yep.
When you have multiple modules or objects, do you put the errors that occur, do you specify the module that it occurred in? And do you put everything in the same error log?
So as it stands right now, there hasn't been a lot of further thought into the, I have lots of sub-pieces. They have their errors, how do they all play together with that? As it stands right now, if you had a bunch of Prime 2.0 modules, they would all have their own logs going in there. And then indeed you can send triggers back up. That is the way that if somebody said, Norm, do that now, I would make the triggers for all modules available so that they could at least send, hey, I'm going to fire a trigger to you to notify that I had an error. And I would send my error up to the top guy and let him handle the fact that me as a sub-module had an error in the guts.
So do you specify where that trigger came from?
That would be very appropriate to populate in there indeed if that was the case. So yeah, not only the action, but if indeed it was the module itself. Possibly maybe even pull some information from the default configuration in there. Yes, absolutely. Part of it indeed would depend on the architecture. Sometimes you want the sub things to be dumb and not send much back, or I think there's. I want to make. We're going to. Yeah, we're just at the edge of time. I will hear often that this is over, and I don't know if I still have them. See, because I'm going to commandeer here for a second.
Yeah, man. I have a grip horse. It's on the machine.
There's the amount of time spent operating the framework is minimal. I would say, underneath normal circumstances, when nothing's happening in the program, or you're just moving between actions, you are going to have the same degree of performance. Well, you can't see it in this one because he's got it in the sub guy. But if nothing's happening, this goes to false. You know, if you're not in the brain, there's nothing that happens there, and if there's no error, this VI becomes pretty much a no-op. And you're left only with what your queue-driven message handler used to be in the first place. So you're still just so if you're okay with the performance and the weight and how much stuff is associated with it, you're really not going to be penalized in terms of performance of the system by using the template. Now there's the other question of, do I really need all this advanced error handling and things of that nature? Well, I made a template, or I used the template to create a template maker, or I used TLB Prime to make a tool to make a new TLB Prime version for you. That is part of what it was. So it's kind of a little bit ancestral like that, or higher, or recursive. It's a better word. Marvelous. To make sure you're awake at the end of the day.
That's
awesome. Really nice. Okay. Anyways. But it's just a dialogue. It's a dialogue that takes 4 inputs, has an OK and a cancel. You'd think, why would Norm use this to make a dialogue like that? But guess what? The very first time that an error happened in the system, I didn't have to think twice about how to resolve it. It just fell into place. So most programs, I would say, you could probably make a dialogue with 3 inputs, an OK and a cancel, without this. But if it doesn't hurt you in terms of number of files on disk, or in terms of your own personal conscience, I would say maybe raise that bar a little bit, that threshold of what does it really mean to be too much? Because most of the time people are like, it only has 3, I don't really need it, and they'll throw this out only to go 2 steps down the road and go, crap. Well, I started making it, I don't want to go back to that, so I'm just going to keep making this again. But next time I'll do it right. However, if they would, now there's a threshold, there's a range, I admit. This might not be appropriate for everything, but I'd say definitely try to stretch yourself along those ways, because I hear all too often, it's just too much. So at least give it a whirl, or try it yourself. Anything else worth noting? Aaron, any last words?
No, I appreciate everyone taking the time to be able to make that happen. Norm's put a good deal of time on this, and hopefully with these continued improvements, things are going to continue to grow. That was some good feedback. We appreciate that. Because what I think of doing and what he thinks of doing and what you all think of doing may not always be the same thing, so hearing those different ideas is very much appreciated. Thank you. Oh, yep. And then before you go, there is a survey. If you could take it, that would be awesome. And then last but not least, I think there's only one more session after this, and everybody go to happy hour. I'm sure at that point in time everyone's going to want to go to happy hour. Could be a very happy hour. All right. That's it. That's all I got, folks. Thank you so much for your time. Enjoy the rest of your NIWeek.